Hello, everybody. So, Alexander and I will talk about a very interesting market trend, the so-called data lakehouses. And we are talking about Exasol's role in that. And we believe we have a very interesting solution for everybody who's currently implementing data lakehouses or planning to do that. But before we start talking about the Exasol details, I want to use the opportunity to welcome and introduce you to our new CPO, Alexander Stigsen. He has joined Exasol a couple of months ago. We are very proud that we couldn't convince Alexander to join the Exasol team. And Alexander, maybe you want to use the opportunity here to introduce yourself and talk a little bit about your background.
Definitely. Well, thank you, Matthias. Yeah, so I'm Alexander Stigsen. I have a long history in databases. I was actually the founder of a database company, a company called Realm, which made a mobile database, which is very, very popular. You might, all of you actually have this apps running in your mobile phones today that have Realm inside them. My company got acquired by MongoDB, so then I spent like many years in MongoDB leadership. And now I've joined Exasol, and I'm really excited to take this to the next level and hopefully apply a lot of what I've learned in my time with databases to this new space. So I'm super excited having joined. I think Exasol is one of the most amazing databases I ever worked with. I mean, the performance profile and capabilities are just out of this world. So this makes it also super, super interesting in this new context. I think the Lakehouse revolution is something that's a perfect fit for Exasol, and it's something that's going to affect basically everybody who works with databases in the next future. I think to actually put it in context a little bit, I will start going over a little bit of the history of databases, because to understand what it actually means, why the Lakehouse revolution actually makes a difference, you kind of have to see where it fits into the whole evolution of databases. So databases are not really a new thing, right? I mean, they have a history that goes back almost to the beginning of computing. And if you look back in like the 60s, you kind of have the invention of what you would kind of say the modern database. And the first databases were very different to what you're used today. They were what's called like hierarchical databases. The most famous one was IMS, made by IBM. And these databases were actually super, super fast, but they were kind of hand-coded. Every structure within it was super hand-coded. And you had this priesthood almost of people who were the ones who could handle the database. So you can kind of imagine in your face, you have all these guys and like having these white doctor's coats on, going around, and they were the ones you had to talk to for any small change you would have to do. And like everything was really, really locked down. So there was this pressure that from the market and from the users that you wanted the database to be accessible and more easy to work with. And this led to a lot of innovation. And the biggest innovation that came was what we today call the relational database. So the idea there was that what if you could actually express in a natural language the structure of your database? Right? With a hierarchical database, you kind of had to build code the structure. And of course, that was fast, but to work with afterwards, but building it was a huge and very privileged kind of job. With the invention of relational database and SQL, which kind of became the defining language of that, suddenly the end user could actually define the whole structure of the database. You could basically, instead of having to rebuild the database all the time, like the user could just go in and define how they want to work with it. And that was like a total revolution. Suddenly, everybody could use a database. And you saw this explosion of new companies coming out. Oracle, of course, being the most famous, that they, like Larry Ellison, he kind of grabbed this opportunity. He saw the future of SQL, and he built Oracle as a giant company based around this idea of kind of democratizing the access to the database. But after that, we have so many databases coming out, and with something like Postgres today being a really, really familiar and popular choice in the open source world, and lots of commercial offerings as well. And it really, really transformed the entire world. But you can say, well, yes, it did succeed in kind of democratizing access, in that the end user could actually start influencing how the database should work and what it should do, and how you to use it. But it still had its own challenges, and the biggest challenge was the login. Right? Really, each database became its own silo. And of course, especially with Oracle, it was kind of well known that you got stuck in Oracle, you were never gonna leave. Right? They would lock you down, and they would milk you for all you were worth. And there was really no way to get the data in and out of this system or use other tools. The cost of doing migration and moving from one system to another was just too high. It was brutally hard. And the problem, of course, came with the transition we now had. That suddenly we had tons and tons of data. The amount of data being generated today by IoT, by like all the users, the internet, everything was just exploding. And at the same time, you are stuck in this silo that was kind of about to explode. And especially like, I mean, you can't, you would be built out of existence, right? So something had to give. And luckily at the same time, there was other revolutions happening. So the next big revolution that happened was the idea of data lakes. So data lakes came from like a thing that that didn't really have anything to do with databases. So Amazon started to launch something called S3 storage, which was a very, very cheap way to store files online. The cool thing about this was that suddenly you could store almost unlimited amount of data in the cloud at a very low cost. So this was a huge difference from the traditional databases. Databases were very, very custom solutions. Yes, you could put your data in there, but it's going to cost you. It's expensive, and it had a really hard time scaling. With the S3 storage and putting stuff in what eventually was termed like the data lake, where you basically just put all your data in there in one big jumble, and then you process from there, this allows you to get basically unlimited scalability. Of course, the problem was how do you actually use this data, which is really the point of a database in general. It's not just storage, you actually have to use it. And we saw an evolution of tools built on top of this to create this. There was Hadoop was the first really big solution there, allows you to do MapReduce jobs and all this data and scale it out to huge data sets. And then later you saw Spark coming in to speed that up. And you saw huge companies being built around this. We had like Cloudera, Mappa, Hortonworks, all these things that was built around the data lake ecosystem. And for a while it worked well. It seemed like this was a promise of unlimited scalability with kind of modular computer on top. But as everything else, when you actually get to use it, you find out that the stairs don't go all the way to heaven, right? So it's not there was always a downside. And for this, I mean, the downside was that there was really no order to this, right? No transactions, no way to control what's going in. We said it was all just getting thrown into the lake in one big mess. So even though you had scale, you could have all kind of weird semi-structured data, you had a lot of freedom. It very quick came that what was termed like as the data lake kind of colloquially very quickly got called into being the data swamp because it was just a mess. It was really, really hard to work with, really hard to actually get value out of the data at scale. So as the history shows, like every time you get to this kind of situation where you have something that's a partial solution, but it's missing something. And for a long while, people wasn't really sure what it was. But then again, a new thing started coming up. And this was the idea of the lake house. So the lake house, even the name is kind of it's like a portmanteau of the data lake and the data warehouse. Right? The idea was, what if you could combine these two things? What if you could have a data lake with unlimited amount of data, but you could have the kind of structure that a lake house that a data warehouse would provide on top of it? If you could combine this, then you would have this ideal, which would be the lake house. So this was an amazing idea because this gives you this idea that you could actually get freedom of the system, that you could actually make it into components. So we saw a lot of technologies coming out here. The idea of commoditizing this whole storage layer on top, and like with the introduction of a few extra things on top. So of course, the data lake part is actually still the same. You have this data lake, it's full of these files containing your data. But on top of that, you introduce a few other things. You introduce like a catalog, which allows you to know what is where. And on top of that catalog, you can actually implement transactions. So you know that when things get changed and it get changed in a consistent manner. And then you get observability, so you can actually see what's going on from the outside, and you can get notified of changes, all these things. So the benefit, of course, is this: suddenly you can have one giant data source. In the ideal world, you remove the login because you can kind of mix and match different components, and you can always use the best of breed components. And you saw a lot of technologies coming out like this. You have Delta Lake, which is kind of sponsored mostly by Databricks, but had huge uptake. Iceberg, which was originally kind of more in the Snowflake ecosystem, but really has spread around now and it is really, very popular. And Hudi, which is a little bit more specialized, but very much for high performance use cases. But all of these three, they're open source, they are seeing very broad industry adoption, and they really allow you to split up your infrastructure in different layers. And for each layer, you can kind of pick what are the best components for your use case, while still having access to all your data and sharing all your data between all these different components, which is amazing. So if you look at the kind of transition here, you had the data warehouse, the original, where everything was in one silo, basically. Then you move to the data lake, and suddenly you could spread out your data, you had it all available, but it all got kind of uncontrolled, unmanageable. And now we move to this data lakehouse architecture, where we have the best of both worlds. You have all these files with all your data, can scale almost unlimited, but you also have this metadata and governance layer in between with the catalog that actually keeps it all under control, so that you can access this from your BI with your reports, and you can access it with AI and everything. So it's a super powerful new architecture, and I think as a trend we can see everybody is gradually moving to this because it just gives so many capabilities. But as always, I mean, as we've seen with the history, every time you introduce one thing, you kind of always hit other problems. Right? Everything comes with its own solutions and its own problems. The biggest challenge with the Lakehouses was two things. First of all, the cost exploding, and then also performance dropping, or becoming really cumbersome. And it's almost become like a meme. It's kind of this is a meme that goes around the web a lot. I see like the data team, they are like, yeah, we want to do all these cool things. Now we got all our data available, and they get it all set up and get started, and then they get the first bill, and wham, they are smacked down, right? And it's like, okay, let's stop. Let's slow down. Let's do less queries, less interaction. This is gonna be too expensive. So this is the reality out in the world mostly that happens when you do this transition. Because you're kind of still working of how to get out of the lock-in with these big vendors that are really expensive to work with. So this is of course where Exasol comes in, right? Because the one thing Exasol is known for, I mean, we are the fastest query engine out there. And in this new world where you can actually plug and play, this means that you can use the best of breed component, and Exasol is the best of breed component when it comes to performance and cost efficiency. So let's look at what that actually looks like. So the idea of being able to split the whole architecture into components is this. So the bottom layer, which is the infrastructure layer, is what we can talk about. This is basically where you have your data lake. This is where the files are actually stored. And mostly it's in the cloud with the big hyperscalers. You have AWS, Azure, Google Cloud. They all have solutions making it easy to basically have unlimited storage of data files. You can also do this on-prem. There's lots of solutions like Mini.io and similar that allow you to do this on-prem, giving you this kind of flexible, unlimited scalability for files. And then on top of that, you have the catalog layer with the open table formats. So primarily Delta Lake, Iceberg, Hudi, they're the big ones, and they interface well with the Databricks and Snowflake ecosystem. They allow you to control all this data, have it as a full Lakehouse infrastructure. And then on top of that, you have the compute. And this is the cool thing where you can totally let go of all the login. Because of course, if you're on Delta Lake on Databricks, you can use the built-in engines. You can use Photon, you can use Spark, whatever you want. But you can also plug in extra engines as you want. And this is where Exasol comes in, because you can just plug in as an engine right next to all the other ones. Totally seamless, just like without even having to change your queries, you can plug it in. And you can just run in parallel with everything else. So we see a lot of people, they will want to put like the most heavy and most complex queries and run those on Exasol. And you can still do ad hoc. You can do ETL in Spark. You can do like a few queries in Photon, if that's the easy thing. It's all coexistent and works beautifully together. And it's all accessible both for the data scientists, for your BI users who likes to sit working in tools, and also today for AI agents, which we see a lot with like OpenAI, Claude, Cohere. All of these engines, they have the ability to directly talk to your analytics engine. So this gives you this super, super powerful architecture where for each level, you can just plug and play and use the best parts you want. So in this case here, you could, for example, you can just pick like in a candy store, right? And say, I want AWS for my infrastructure. I want to use Delta Lake for my Lakehouse, Exasol for the analytics engine, and then I'll use an MCP server with Claude for my AI agents and the Jupyter notebooks and Power BI for the users. And you just plug this together, put it together, your ideal infrastructure. And at any point in time, you can actually move between the individual parts. So that is the beauty of the data lakehouse. It gives you this optionality, turning it all into like Lego bricks you can put together yourself and optimize. So let me hand it over to Mathias again, because this is all good in theory, but let's talk about the reality. How does this actually work when you work with real customers in the real world?
Yeah, thanks, Alexander. I believe it's really an interesting, exciting market trend. And the architectures of the future will very often look like that. And that's why Exasol has built a smooth integration into these platforms. Actually, that's an amazing opportunity, a door opening up for Exasol because we can concentrate where we are best in. We can concentrate on our DNA being the fastest query engine in the market. But what is important to integrate into that architecture? So first of all, it needs to be zero effort integration. So you don't want to add additional ETL processes, data integration. The data lakehouse should be the unified data platform where you collect data, where you integrate data, and then where you provision data for data insights. And that's why we've developed integration called a caching service. So that data is actually sitting in the lakehouse, but then a user can define what parts of that lakehouse should be accelerated and cached with an Exasol. And from there, the rest is done automatically. So we have built a complete new fast Parquet loader, 10 times faster than the old one, which is accessing the data and caching it inside Exasol. And the caching service also includes a change data capture functionality, so that only the changes under the hood are automatically synced in the Exasol cache. Now, end of last year, we were actually approached by a Fortune 500 company which was implementing a Databricks platform to unify all their data within one open lakehouse. So they have nearly 300 data products, several petabytes of data, but they had exactly the problem Alexander was pointing out. They were hitting hard on the cost constraints. So the costs were exploding. And that's why they had been reaching out to Exasol asking for a solution for that to reduce the cost. So it was not actually about acceleration and fastest data queries. It was about reducing the costs. And so that company was in good companion with many, many other companies in the market. We have just seen a very interesting market survey where 40% state that their number one pain point with the lake houses is cost. The second pain point is actually the lock-in within that platform vendor. And the third one is performance. So all these problems, Exasol has a very interesting solution for. Now that company was approaching Exasol and they did a proof of concept, a use case, a real finance use case, tested against Exasol, and they wanted to compare their existing Databricks installation with that kind of setup. So now the question was, how much more efficient could Exasol be? So Alexander, maybe you can switch to the next slide. The question was, is it 10% faster or more efficient? Is it 20, 50%? And company was actually blown away. We were testing 100 concurrent queries against their data set, and the result was staggering 182. So that sounds maybe crazy. 182 times more efficient that Exasol uses a certain infrastructure compared to Databricks Photon. Let me explain a little bit how that comes and what the details are around that. So what the company tested was one database cluster. On the bottom left, you see that these icons indicating the infrastructure which was used. So Exasol just was using one database cluster, and with the Databricks live production system, they were spinning up 13 concurrent database clusters. Why is that? The reason being that for 100 concurrent queries, that workload, Databricks typically needs a whole bunch of database clusters because they are scaling in a different way like Exasol. So every 10 or 12 concurrent queries, you need to spin up an additional database cluster. With Exasol, you can actually run hundreds of queries within one database cluster very easily. And then at the same time, each query is still executed faster than the third on Exasol compared to the 13 database clusters on Databricks Photon. So in summary, company tested 14 times more throughput on a single database cluster compared to 13 Databricks Photon clusters, which is then resulting into more efficient usage of infrastructure of 182. But what was even more important for that company was not just speed and acceleration, it was actually the cost. So in summary, the expectation is now that the cost reduction is factor 4. So 4 times less costs on Exasol compared to the existing Databricks Photon engine. Why is that? So if you look at the numbers before, the expectation is with all the different use cases, you also have certain times in the week where you don't have a concurrency of more than 100 users in parallel. So the expectation for that customer is a cost reduction of factor 4. That is, I mean, I quote that company, that will be a game changer. So we are now in the process of putting Exasol in production. And the smart thing about that is, first of all, there's no extra migration effort. You can simply plug in and enjoy. Secondly, you can use Exasol without any risk because you can run both query engines in parallel. So you can, anytime you can switch back and forth from the different alternative query engines. So that's an amazing story. And it's also very encouraging for us as Exasol, being an amazing query engine vendor in that market of open lakehouses. And yeah, we're looking very much forward to the next steps. So Alexander, maybe you want to start talking about the summary of our value proposition in that regards.
Yeah, definitely. I mean, the thing you come into is the essence here, right? The cost savings and the predictability of cost, which is also really important, which is something that Exasol has always offered, are key. And because the thing is, when you have high cost, it's not just a matter of money, it's also a matter of what you can do. And I think this is the thing we see when we talk with data science teams, that the moment that you see these giant bills, it means that everybody gets held back. It's like, no, don't run that query. Maybe you should wait with that query. Maybe you should spend like a few days more optimizing the query, or wait until everything else is done. And it holds you back, and it does means you don't get that experience you want. So I think, at least from my experience, the most important part is that it gives a better experience for the end user to have this. The moment things get cheaper, especially at this degree cheaper, like 4 times cheaper, then it means suddenly that you don't have to gatekeep everything. And as a team, you can say, okay, you can run the queries you want when you want, and you can do ad hoc things, you can experiment, and it gives you a totally different freedom to actually do what you want and get it done quick. So it just helps you get your job done much faster. And that's really the feedback we get. And I think this is where the real value is. And then, apart, of course, then there's the ease of use that Mathias talked about.
Yeah, then of course the smooth integration, so the zero ETL integration, you don't need to do any additional efforts. You simply plug in, as I said before, and enjoy Exasol and its amazing in-memory MPP architecture. But what is maybe also interesting and very important in that sense is our self-tuning operation. So you don't need to tune. Exasol has a very robust optimizer, and you can run very complex queries and through automated data distribution, auto indexing, auto data compression, and many more, Exasol is actually very robust if you want to throw ad hoc queries against your database. And maybe another dimension, which is coming back to the use case of that Fortune 500 customer, they had been pushed and forced actually to tune Power BI reports, standard BI tool reports by native queries to tune the cost impact on the Databricks Photon queries. With Exasol, they can also get rid of that dimension and simply run their BI reports without any additional manual interaction. So that's really the key use piece of that new solution, the Exasol Lakehouse Turbo. And the great news is, Alexander,
Yeah, the great news is it's available today. I mean, all these capabilities of getting lower cost, higher performance, something that just works, plug it in and it just works. This is all available today, right? All you have to do is contact us and say you want to join our private preview, and you will get access to this, and you can actually play with it and try it against your own data. So it's not just, I mean, you can always say, yeah, things, everybody claims it faster. This is something you can actually just try right next to your other engines on your own data today, and you can make your own judgment. And I think you'll enjoy it. Thank you guys, and thank you for joining in. And again, if you want to try, reach out.
thanks everybody.